Good morning, friends and dear students. It gives me immense pleasure to be here again for my course, Aircraft Systems. Today I am in definition and the terminology of my module 4, module 5, and this module 5 is Flight Control System. As you know, my name is Dr. Dwivedi, Professor from Institute of Aeronautical Engineering, Hyderabad, India. Today's topic, I am going to discuss about topics and the CO mapping. All these COs are mapped with CO6. Today I am going to discuss about flight control systems, canard and flight control surfaces, primary and the secondary control surfaces, mechanical control, fly-by-wire, actuators, and so on. First, I will go with define flight control system. So here I have shown a diagram. So a conventional fixed wing aircraft flight control system consists of flight control surfaces, the respective cockpit controls, connecting linkages, and the necessary operating mechanism to control an aircraft direction in flight. Aircraft engine controls are also considered as a flight control as they change the speed. So flight control, here this you can see in this, we have here primary control surfaces are aileron, elevator and the rudder, and this aileron will change the roll. Axis of the rotation is longitudinal, type of stability is lateral. So ailerons are used for lateral stability, elevators are used for the pitching, axis of the rotation is lateral and they are depend upon the longitudinal stability. Third one is the rudder. They are used for yaw purpose. The axis of the rotation is vertical and type of stability is directional. Just a simple, I will explain here what is meaning of this. So first I will discuss about the axis. So the axis which is passing from nose to the tail, it is called the longitudinal axis. The axis which is passing from the wing tip to via center of gravity is called the lateral axis, and the axis which is vertically passing in the intersection of lateral and the longitudinal axis via center of gravity is called the vertical axis. So here are the ailerons. These are the ailerons here, and they are fixed on the wing. Here at the horizontal tail we have the elevator, and at the vertical fin we have the rudder. This you can see, it is mentioned here. This is the rudder, this is the elevator, and these are your ailerons. So here if you want to roll, so this rolling is happening with respect to the longitudinal axis. So here mentioned, if you see here, roll here. This roll is on longitudinal axis and this is happening by the aileron, and this will affect the lateral. This is called lateral stability. Rolling is lateral stability. The next one is the elevator. These elevators are used to make the pitching, and this axis of the moment is with respect to the lateral axis. So it is mentioned here lateral, and this makes the pitching stability. Okay, so if you move up and down, your nose will go up and down. So it is called the longitudinal stability. So if you operate the roll, it will give the lateral. It is a rolling lateral stability. If you are pitching, you are using the elevator, pitching the aircraft, it will give the longitudinal stability. And next one is if you are operating the rudder here, if you operate the rudder, yaw will be there like this, yaw, and this is making sure that directional stability is achieved. So that is the flight control system of the aircraft. Next is very important is nowadays we use the canard. So what is canard wing configuration and what is its utility? So here I have shown a diagram of Saab 37, first modern fighter with canard. First time this Saab Gripen of Sweden, they have used this the canard, and these are the canard here. This one is this one. Canard is nothing but a four wing. before the wing we use small wing and we avoid the tail. The horizontal tail is avoided. So that is called the canard. A canard is a wing configuration in which a small forewing or a foreplane is placed forward of the main wing of a fixed wing aircraft or a weapon. The term canard may be used to describe the aircraft itself, the wing configuration of the foreplane. Canard wings are also extensively used in guided missiles and the smart bombs. An aircraft designer may adopt the canard configuration to reduce the main wing loading. So, what is the benefit is main wing loading. To better control the main wing airflow or to increase the aircraft maneuverability, especially at high angle of attack or during a stop. So, these are the advantages, and students can work on this to find out in a wind tunnel by using this canard configuration, and you can find that what is the advantage of this canard configuration. I have also published few papers also recently, so this you can refer in Google Scholar or anywhere. You can get some my paper also. I have done some experimental work on this. Canard foreplanes have important consequences for the aircraft's longitudinal equilibrium, static and the dynamic stability characteristics. So here we have some consequences also. So longitudinal equilibrium will be disturbed, static and the dynamic stability of the aircraft will also be disturbed. So we need some autopilot to make this aircraft work. Only human powered aircraft or human operating aircrafts is somewhat difficult. That is why it was not used. The first aircraft was started by the Wright brothers, and the first aircraft was itself as a canard configuration. But after that, only few aircrafts have come, and I am going to discuss these things about the historical of the canard configuration. Very good thoughts are here, and different peoples they have used for different purposes. If you see here, we have here, these are the canard. Here we have the canard here. So the Wright Flyers of 1907 was a canard biplane. Then Curtiss Wright XP-55, they are also used the canard very far away. Then the Yungshu Sinden scale, they also use the canard here. Then we have used a very experimental bomber XB-70. They also have used a canard configuration, and also Jazz 39 Gripen, same company of the Sharp, they also used here. But you can see different locations are there. It is far away from the wing and it is very close to the wing. Next, Su-47 is also having the canard with forward swept, and then Aero Typhoon, they also have used the Rafale, and all aircrafts are nowadays are having the canard. So it is very good, interesting topic. We can work by using the CFD or some softwares, or also you can use your XFLR software for a basic understanding. Also you can make a model by the 3D printing and do the experimental work on the wind tunnel as per availability of the high speed or the low speed or the mid speed, in which condition it is useful. So what is yaw control? So yaw means nose left or the right with respect to the vertical axis, and this control is done by the rudder. This you can see here. This is the rudder here. So if you rotate the rudder left, nose will go left. If you make right, it will go to the right. So yaw control is provided by the single rudder section for high performance aircraft. Yaw control is generally less important than for the conventional aircraft due to the high level of excess power. There are nevertheless certain part of the flight envelope where control of yaw or side slip is vital to prevent roll yaw divergence. So sometimes we need in high performance aircraft also, and it is done by the rudder. And this you can see most of this have different types of rudder. This you can see like V shape here this. So in this also we can work. Very good research we can do by the different rudder configuration or the vertical tail configuration of the aircraft. What is the secondary flight control system? The secondary flight controls are intended to improve the aircraft performance characteristics or to relieve excessive control loading and consist of high lift devices such as slat and flaps as well as flight spoilers and trim system. Secondary flight systems may consist of wing flap, landing edge devices, spoilers and trim control systems. So here secondary flight controls are shown here. These are the flaps which is at the trailing edge and the slats are at the leading edge. Spoilers are at the center and this you can see the secondary flight control, how these things are operated. This you can see here that they are the flaps and they can be operated by different spring tabs, trim tabs. These things are done here. Define auxiliary flight control. The auxiliary flight controls are the trailing edge flaps, leading edge flaps and slats, the spoilers and an adjustable horizontal stabilizer. These things are shown here, slats and the slot here, spoilers are here, flaps are here, and these things are called the auxiliary flight control systems. Define flap. Flaps are a high lift devices consisting of hinged panel or panels mounted on the trailing edge of the wing. When extended, they increase the camber and most cases the chord and the surface area of the wing, resulting in an increase of both lift and drag and a reduction of the stall speed. So here the flaps are high lift devices consisting of high hinged panels or a panel mounted on the trailing edge of the wing. So this you can see it is a basic wing, and here if you see this is a split flap here and here a plain flap and this is the split flap. If you see here it is slotted, in this it is extended, so this camber is increased. Initially the chord was like this, it is a chord, now the chord is here, so the camber of this thing is increased, so it will give high lift. And the same way different types of our flaps are here. This is plain flap, split flap, slotted and the fowler, it will extend. It is here but it will further extend, so it will give more area, and if you see from here to here a huge amount of this thing chord and the camber has been changed. Change in big way comparing to others. So this is the purpose of the define the flaps of the aircraft. Then what is the spoilers? Spoilers are here on top of the wing. These are the spoilers here and here, a series in all the wing area from the root to the tip, some leaving 10 to 15%, and here also this you can see from here to here and here also. So these are the spoilers. So what is the spoilers and how it is used? Spoilers on low drag aircraft like sailplanes, spoilers are used to disrupt airflow over the wing and greatly increase the amount of drag. This allows a glider pilot to lose altitude without gaining excessive airspeed. Spoilers are sometimes called the lift dampers. Spoilers that can be used asymmetrically are called the spoileron and are able to affect an aircraft roll. So if you want both wing, if you see this one, if you use equal amount in the left and the right wing both, you raise, it will spoil. But if you increase one side or you lift spoiler in one side, then it will roll also and also it will yaw. So rolling and yawing also can be performed by the help of the spoiler for the low speed aircraft. defined wing vertex generator. So what is the wing vertex and how it is useful for our aircraft? So what is the wing vertex? You know that if you see the wing after some distance from the leading edge, the air starts separating. If the air starts separating, then the separation will take place and the drag will be increased, lift will be reduced, because the effective wing area which is supposed to increase the lift is not taking part in generation of the lift, and some 20%, 30% as you increase the angle of attack, the more area is not taking part in generation of the lift. This makes the aircraft ineffective. The aerodynamic performance of the aircraft is reduced. To further enhance in this type of situation, we need the wing vertex. Okay, and it is called the vertex generator. In short, we say as a VGs. So, wing vertex generator, in order to reduce the drag caused by the supersonic flow over portion of the wing, small airfoils called vertex generators are installed perpendicular to the surface of the wing. They are mounted in complementary pair. This causes the vertices being developed to aid one another, thus increasing the effect. On some aircraft, fences are installed on the wing and in ailerons. This gives more stability and control of the aircraft, reducing buffeting and reduced high speed stall characteristics. So here this you can see the diagram here. Like this, airfoils are, just you can see like this. So air will enter from this side and they are made like this. This you can see here, a series of these things are in Boeing 777. It is there. So this will enhance the kinetic energy and it will reduce the drag, and other way the economy or the fuel consumption of the aircraft will also reduce. Also the delay in stall will also happen. So it is very good technology of the vertex generator. Next is another drag reduction device which most of the aircrafts nowadays are having, especially the passenger and the this aircraft. So winglets are, so define winglet and fence. Winglets are vertical extension of wingtips that improve an aircraft fuel efficiency and cruising range. So it is the purpose of it to reduce the drag, and due to the reduction of the drag, the fuel efficiency, the fuel consumption of the engine is reduced and the cruising range is tremendously increased. Designed as a small airfoil, winglets reduce the aerodynamic drag associated with vortices that develop at the wingtip as the airplane moves through the air. So here if you see, this is the winglet, and this has made that 7% of drag is reduced. So if you are able to reduce 7% of the drag, the fuel consumption may be reduced by 9 to 10%, and it is in the billions of dollars airlines can save in a whole year. So that is the very effective. That's why most of the aircrafts, those who are not having the winglets, are now converted to the winglet and they are using this benefit. Next is very important is the fence. This you can see here, one old aircraft here. These are the fence are used on the wing. So wings fences, also known as the boundary layer fences, and potential fences are fixed aerodynamic device attached to aircraft wing. So this is also used that interferences of your fuselage should not go to the remaining wing, so that the smooth flow will be occurring on the wing. Next is Discus mechanical push-pull system. So it is a flight control system. So we have to understand what type of flight control systems are used in aircraft and how this can be achieved. So first thing is mechanical push-pull system. A stiff rod or hollow tubes in an aircraft control system that moves a control surface by either pushing it or pulling it. Moment of the cockpit control transfer force through the cable to the bell crank, which moves the control surfaces. In the push-pull control rod system, metal push-pull rods are used as a substitute for the cables. Push-pull rods get their name from the way they transmit power. So why we tell as a push or the pull? Push or the pull. So like this, pilot is making is pushing and the pulling. Pushing and the pull. So just you can see here, this is the control stick and this is called the push. And if it is moving, it is called the pull. And here is the pilot. Okay, so these rods are moving and these rods will give everywhere push or pull and push or pull. So push or pull. So like this, it is called the push-pull rod. What is flight control actuation? So we have to understand that what type of flight actuations we can do. So a conventional fixed wing aircraft flight control system consists of flight control surfaces, which just now I have discussed. So what are the flight control surfaces? If you see, rudder, elevator and ailerons. These are the flight control system. The respective cockpit control, connecting linkages and the necessary operating mechanism to control an aircraft direction in flight. Aircraft engine controls are also considered as a flight control as they change the speed. So here, what is the meaning of actuation? So this flight control has to be actuated. Actuated means it has to move by help of some mechanical, hydromechanical, electrical or combination of these all things. Nowadays, the fly-by-wire or the autopilots, the hydraulic jacks, the hydraulic servo valves, these things are used to actuate the flight control. So these things we have to understand. Next is the fly-by-wire flight control system. Initially we were having mechanical. I have shown you as a push-pull type, then hydraulic type, then electrical type. But after that, what happened that these were having a lot of problems of mechanical failure, their bearing failures, their crack, and so many things. And a lot of accident used to happen. To avoid that, some 20 years back, the fly-by-wire control system was developed. So a fly-by-wire FBW system replaces the manual flight control of an aircraft with an electrical interface. So we need some electrical wire, switches and the wires, and it will be given to the actuator and the actuator will operate. Here we don't use the push-pull rod and so many things. The movement of the flight controls are converted to electronic signal transmitted by wire. Hence the term fly-by-wire has come, and flight control computers determine how to move the actuators at each control surface to provide the expected response. Command from the computers are also input without the pilot's knowledge to stabilize the aircraft and perform other tasks. Electronics for aircraft flight control systems are part of the field known as avionics. Fly-by optics, also known as the fly-by-light, is a further development used fiber optical cables. So now we use the fly-by optics or the fly-by-light. In that we use the, in place of wire, we use the fiber cables. Define fly-by-wire actuation system. Here, this we can see here that there are the three modes of this: full FBW mode, direct electrical link mode, and mechanical reversion mode. So pilot has to select which mode they want to operate the aircraft. If it is full FBW modes, pilot need not to do anything. Then direct electrical link mode. So this is dependent upon the pilot. Pilot will operate the switches and it will work. And mechanical control electronics, AC, this mechanical reversion mode, totally mechanical, as and when pilot will have full control on the system. So here this we can see a diagram, that is the pilot. Here we have the FBW command and here we have the direct electrical link. These two are here shown. Here is the hydraulic, and this will be going to the actuator control electronics, ACE, and this here we have here analog loop closer. The hydraulic power will be in this actuator, and the feedback of this, how much it is going forward or the rear, it will be again given to the actuator control unit. As for the pilot instruction, here or it is autopilot instruction. These things will be operated, and this is a very simple fly-by-wire actuation system. Define trim and feel. Trim and feel devices provide pleasant handling characteristics of the aircraft. So if the aircraft is flying and pilot is operating the whole control like elevator, radar and all, but they may not achieve the exact what they want. So to have a proper smooth flight, they have to trim. There are some trim types here. These trim types will work, and they will give the aircraft a exact location and exact condition. It is shown here that weight, as the lift is increased, then trim force for the maneuver, it is more than the trim force for the cruise. So like this it is working. Define fly-by-wire control laws. Here we have the three laws. Normal laws, it is called basic control laws, alongside conditional algorithms, help to detect failure and to revert the system to alternate law. So basic control laws alongside conditional algorithms helps to detect failure and to revert the system to alternate law. So it will detect the normal law, it will work in the normal condition. As and when some problems happen, the algorithm which decide, it will convert this normal to the alternate law, and it will work in the alternate law. So what is the alternate law? Basic control laws without any additional handling. In case of any further failure, it should revert to mechanical actuation. So if the one failure happen, it will convert to the alternate law, and if alternate law again fails, then it will give signal to the mechanical actuation, and this mechanical actuation is called the direct law, direct relation from control stick to the control surfaces. A pilot will operate directly without any intervention of any fly-by-wire system. This you can see in this diagram. The normal law is working here. Most double failure, computer, hydraulic and the ailerons, then it will go to the alternate law. If any failure is happening in this, it will go to the alternate law. If this alternate law, if there is some failure here, it will go directly to the mechanical reversion. If you see here, the certain triple or double undetectable failures are happen, it will go again to the here the direct law, and this direct law or this alternate law, both will given last to the mechanical reversion, and this mechanical reversion means total mechanical control of the aircraft by the pilot is achieved. So this type of three control laws are applicable. So here these are the references: Moir I and the Seabridge, aircraft systems, mechanical, electrical and avionics system. Then the next reference is again from the Moir and the Seabridge, design and development of aircraft systems and introduction, AIAA education series, AIA 2004. Any questions, you are welcome to ask me. My email is ydwedi@gmail.com. You are welcome to ask any questions. Please like and subscribe this channel. If any comments, please give in my this channel. Thank you very much. I will be again going for the next lecture. Be with me and be tuned for my next lecture. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.